All right, today I want to do a video for quadratic equations graphing from standard form, which is ax squared plus bx plus c. And I'm going to use x squared minus 2x. The first thing I want to do is find my axis of symmetry, which is negative b over 2a. For this equation, I have, let's just pretend there's a 1 there, negative 2 for b and 1 for a. So a is 1, b is negative 2. I know that because the equation says ax squared plus bx plus c. So a is the number in front of x squared. Since there's one x squared here, even though there's not a number, it's still like there's a 1 there. And then I have bx, but the equation says plus bx, so it's minus 2. And there's no value here for c, which if you wanted to put a plus 0, you know that c is 0. All right, so I'm going to plug in negative 2 for b. So make sure you put negative on the outside as well. Those are going to cancel out. And then I have a of 1, so 2 times 1 on the bottom. So 2 divided by 2 means my axis of symmetry is at 1. Technically at x equals 1. All right, I'm going to draw a little graph for this. Hopefully I give myself enough room. A is positive, so my graph is going to open up. If you have your graphic organizer, it tells you C is where your parabola is going to hit the y-axis. So this is your y-intercept. So it's going to hit at 0. So either it's right at 0 or maybe it goes up like this across 0. So I don't need a whole lot of negative numbers. All right, so I'm just going to make this look as good as I can. It doesn't need to be perfect. When you're graphing, everything is an estimate anyways. But it will give you an idea of what it should look like. All right, so our axis of symmetry, that's the line it's reflecting over, and that's here at x equals negative 1. So it should come down, hit down here somewhere, and come up. All right, so we have the x value here. We want to find the y value, and that's going to tell us, the x and y will tell us where the vertex is. So I'm going to take the x of 1, and I'm going to plug it back into the original equation. All right, 1 squared gives me 1. 1 times 1 is 1. And negative 2 times 1 is negative 2. So y equals negative 1, which means my vertex, a little messy here. My vertex is at x of 1 and y of negative 1. All right, so 1, negative 1. And I want to do at least 2 coordinates on either side. So I'm going to plug in negative 1 and 0 into the original equation and see what I get. So give yourself some space for this if you need to write out the equations as you're solving. So I want to do -1 and 0. I know they should reflect on the other side, and I already know what this is, but I'm still going to do 1, 2, and 3 just to make sure that all my math is correct. So if you're trying to make sure that you get everything right, you should always check your work. Okay, I'm going to leave a little space here so that I can write it out. So -1 squared minus 2 times -1. All right, so -1 squared is 1. -2 times -1 is 2. And 1 and 2 makes 3. And then I'm going to plug in 0. 0 squared is 0. And -2 times 0 is also 0. Then I've got 1 squared minus 2 times 1. 1 squared is 1. 2 times 1 is 2. 1 minus 2 is -1. Now I should get 0 and 3. Since I know this is my vertex, it should be reflecting on either side, but I'm still going to plug everything in and just make sure. So 2 squared minus 2 times 2, which is 4 minus 4, so it's still 0. 3 squared minus 2 times 3. 3 squared is 9. 2 times 3 is 6. And 9 minus 6 gives me 3. So that means all my math looks good. I'll go ahead and plot them. This is 2, 0. Here's 3, 1, 2, 3. And then the other side is at 0, 0, and -1, 1, 2, 3. So this isn't going up very fast because the one value was, or I'm sorry, the A value is 1. Remember, think of A as being like your slope. The bigger it is, the faster it's going to go up or stretch up towards the y-axis. And the smaller numbers, like a decimal or fraction, is going to make it go up slower. But that looks more like a parent function. It's just a little bit away from the origin. All right, so we have the vertex, the axis of symmetry. We've got the points labeled. The only other thing that you need to know is where the zeros are. So if y is 0, x is 0. We've got y equals 0, and we have twice that it crosses the x-axis, which is usually what happens. X is 0 and x is 2. These are important with word problems a lot. When you're looking at something going up out of water and you want to see when it comes back down and crosses again, something like that. Or a rocket going into the air, how long is it going to take before it comes back down? And that's it.